Hi everyone, welcome to another edition of our online program where we give detailed solutions to past examination questions. So in this episode, we will be looking at one of the past examination questions, and I hope you will enjoy. So let's get started. Now, question 1: which of the following instruments is suitable for making the most accurate measurement of the thickness of a wire? Now, when you talk about the thickness of a wire, we have most especially we make use of these two: micrometer, screw gauge, or vernier caliper. But this is the difference. The difference is if the size we are measuring is small, make use of micrometer, screw gauge. Small diameters like that of a wire, a piece of paper, and all of that. Then you talk about vernier caliper when you talk about measuring the diameter of let's say the thickness of a pendulum bulb, something relatively big, bigger than that of wire. So in this question, the answer to this question will be a micrometer, screw gauge. Now let's see the second question: the motion of the wheel of a bicycle. The wheel of a bicycle will everly demonstrate a rotational motion, and for the fact that is on a bicycle that is moving on a smooth straight road, from the word straight, that will translational motion. And if you check here, it's not oscillatory no, so I go between this and this. Random, no, so I go for rotational and what? Translational. Now let's see question 3. In question 3, we have the following are devices used at derived units. Sorry about that. Except, now this is a derived unit. The following are derived unit except this is a derived unit. This is the unit of density, the unit of force, weight, reactions, or anything that has to do with force. Why this is the unit of impulse. This is the unit of volume. All these are derived units. This is the unit of mass. Mass is a fundamental unit, so the answer to this question will be E. Now let's see question 4. A stone of mass 0.7 kg is projected vertically upward with a speed of 5 meters per second. Calculate the maximum height reached. In this case, we are given the speed and we are asked to calculate the maximum height reached. So we have U to be equal to 5 and we have H to be unknown. So in this case, we will be using the formula V squared equals to U squared plus 2GH. But in this case, at maximum height, do not forget your V will be equals to 0. And for the fact that G will be negatively, it will be negative, yes, because the motion is upward. That's upward motion here. So if that is the case, you will be having something like this is 0, so you have this will be 0 equals to U squared minus 2GH. So you may want to solve for H here. H will be U squared over 2G. And what is your U? Your U, what's your H? Sorry, you have your H here. Your U is 5. That will be 5 times 5 divided by 2 times 10. And if you do that very well, that should give me 5 here to 4. 5 over 4 should give 1.25 meters. That's option A. So let's see. The next question is, we were told that in the diagram above, calculate the magnitude of the couple. Normally, this shouldn't just be an ordinary couple. It should be the moment. It should be moment of a couple. So if that is the case, that will be force times the perpendicular distance. And here, since it's couple, we just pick one of the force. So you have 10 times 0.25, which is the distance between the two arms. So you have this to be 2.5. That will be option D. So we'll go to question 5. Question 6. In question 6, a body moves along a circular path with a uniform angular speed. So we have the uniform angular speed here, which is 0.6 rad per second, and constant speed, that will be your tangential speed, which is 3.0, and you have to calculate acceleration. So here we look, we will be using this formula, A equal to, that should be omega V. Yes, omega v. So in that case, you have omega is 0.6 times speed, which is 3. The answer should be 1.8 meter per second squared. And that's option B. Number 7. In number 7, you have 3 non-parallel coplanar forces which can be represented both in magnitude and direction by the 3 sides of a triangle taken in order. In this case, I think they're talking about equilibrium here, most especially when you hear things like non-parallel coplanar forces. So yeah, we have something like this. So in this case, one of the things you must note is that one of them can be the equilibrant. So here we have any one force being the equilibrant of the other. This is correct. Make a body move randomly, no. Make a body oxidate, no. Move a body along a straight line, no. Rotate a body about its axis, no. And that means our option is option A. So now let's go to question 7. In question 8, we have which of the following will reduce the frequency of oscillation of a simple pendulum? In most cases, the relationship between frequency and the length of a string, talking about simple pendulum, is inversely proportional to the square root of the length of that string. So in this case, that means if you're talking about, here we have reduce, so if you say reducing frequency, then you must be what? Increasing length. So if you check here, this is reduce the length, no. Increase the amplitude, no. Amplitude has nothing to do with the frequency. Increasing the frequency of the string, this will be correct. So yes, this is correct. And reducing the mass, no, that doesn't have anything. Mass has nothing to do with the frequency of oscillation, be it frequency or period. That has nothing to do with it. So we go to question 9. In question 9, we have a simple pendulum is this long, has a period of this. Calculate the period. Here you are given 2 periods. If you check very well, so in this case we will be using the concept of 2 cases. Now let's see. First of all, let's establish the relationship between period and length. In this case, if frequency is inversely proportional to the square root of length, you agree with me that period will be directly proportional to the square root of length. So for 2 cases, you are going to have T1, T2 equal to square root of L1 over what? L2. So if that is the case, let's see how this works. Let me put in their values. First, we have L1, which is the first length, is 0.64 divided by the second length, which is 0.36. You may want to use calculator there. So yeah, if you have 0.64 divided by 0.36, find the square root, you will get 1.33. So here you talk about T2 to be equal to 1.2 divided by 1.33. And if you do that very well, your answer should be 0.9. So that would be option B. So let's go to question 10. In question 10, the amplitude of oscillation of a simple pendulum bulb diminishes slowly because energy is applied by some external force, no. Frictional force dissipates the energy of motion, this is correct. Frequency, no. Frequency has nothing to do with the amplitude, as we have mentioned initially. This is also frequency, this is also period. So none of this has anything to do with the amplitude of oscillation. So the answer to this question 10 is B. So quick one. Question 11. In 11, a projectile is projected with an initial velocity u at an angle theta to the horizontal. Maximum height, you agree with it that maximum height is given as u squared sine squared theta all divided by 2g. So let's find out the one that will be our answer here. Oh, sorry about that. None of them is correct. So this will be the answer to this question. Let's go to question 12. The length of simple pendulum is increased by a factor of 4. By what factor is its length, is its period increased? Do not forget we've said that period is directly proportional to L. So the length. So if the length is increasing by a factor of 4, if you put 4 here, what will be the square root of 4? 2. So that means the period will increase by a factor of 2. So let's see, that will be option D. So we'll go to 13. Which of the following is a non-renewable energy source? The answer to this question, yes, coal is non-renewable, hydro is renewable, ocean waves is renewable, solar energy is renewable, tides are renewable. So in this case, the answer to this question is A. Don't forget, when you say non-renewable, that means after used, you can't get it back. You can't convert it to any other form. Are you getting it? So when we say a non-renewable energy source is the one that cannot be replenished after being used. So now let's see number 14. A body is pulled a distance s along a smooth horizontal floor by a force of magnitude F inclined at an angle theta to the horizontal. The work done is, let's say we have something like this. So you have this force F, and this is the horizontal. So in this case, whenever you are giving things like this, you all know that work done is what? Force times distance, isn't it? So that means if I resolve this force horizontally, I'm going to have F cos theta, isn't it? So in that case, it's going to be F cos theta multiplied by the distance x, and that will be Fx cos theta. Fx cos theta. So your option A is correct for question 14. So let's see the next one. Which of the following statements is correct in any machine? In any machine, you have the first thing first. The velocity ratio is usually greater than the mechanical advantage. That is correct. Efficiency is work input. No, efficiency is work output divided by the work input. Yes, so that's not correct, and you have multiplied by what? 100% here. So let's say the velocity ratio is independent of friction. This is also not correct. So the answer to this question is option A. Option A. So let's go to question 16. Which of the following statement is true of two bodies involved in an inelastic collision? After collision, kinetic energy increases? No, it should be decreases. Yeah, should be decreases. Momentum decreases? No, this should be conserved. That means it remains the same. Their velocities are the same? No, the velocity changes. So this should be none of the above. Okay, sorry about that. There is no option here that has to do with none of the above. So we go to question 17. In question 17, we have an object of mass 5 kg moving with a velocity d due north. So we have something like this. It's moving due north, and the mass is 5 kg, and it's moving with a velocity of 12 meters per second. It's a stationary body, so a stationary body will be somewhere here, and because it's stationary, u is 0. And what about the mass? The mass is 7 kg. So what happens? This is before collision. So what happens after collision? They stick together after collision. So you have them sticking together after collision. So you have this, and if that is the case, let's see how this works. You're going to have the total mass here will be 7 plus 5. That gives you 12. You are asked to calculate the speed. Momentum generally is mass times velocity. So in this case, we have two bodies. The first one will be 7 times 0, plus second one will be 12 times 5 equal to 7 plus 5 multiplied by v. Now do not forget that under momentum we love to take into consideration the direction. If they are moving in opposite direction, one will be positive, the other will be negative. But if they are moving in the same direction, they will all be positive. Are you there? So in that case, we have this is 0, this is 60, equal to this is 12v, and of course 12 here 1, 12 here is 5, so your v is 5 0.0 meter per second, and that is option D. So question 18, a constant force acts on a body of mass 50 kg and changes its speed from 20 to 90 in 10 seconds. Calculate the magnitude of the force applied. This is the application of Newton's second law of motion, and you have F equals to m bracket v minus u over t. So if that is the case, you are asked to calculate the magnitude of the force equal to the mass, which is 50. The final speed is 90 minus the initial speed, which is 20, and you divide by time, which is 10. So in that case, you have, this is 70, so you have 5 times 70 will give you what? 350. So that makes option D the answer to this question. Now 491 Kelvin is equivalent to what in degrees Celsius? Do not forget that in Kelvin you have 273 plus degrees Celsius. So if you are to calculate for degrees Celsius, it's going to be in Kelvin, which is 491 minus 273. And if you do that very well, this should give you 8. This should give you 1, and this should give you 2. So you have 218 degrees Celsius, and that's option B. So the next question is, in which of the following is the expansion of solid a disadvantage? Yes, we all know that the answer is the balance wheel of a watch. So number 21, when some ice cubes are added to a glass of warm water, the glass is cooled by a process of, for the fact that this water is warm and is in a glass, we have the conduction of heat by conduction established first, and for the fact that ice cubes are also added, you have the second mode of heat transfer, which is convection, also established. So in this case, we have the combination of conduction and convection, and that's option C. So now let's see, in the next one, you have two metals, A and B, lose the same quantity of heat. They lose the same quantity of heat when their temperature drops from, so that means they have the same temperature change, okay? So if the specific capacity of A is thrice that of B, that means you have something like this, and for the fact that the quantity of heat lost in A is the same thing as the quantity of heat lost in B, and the change in temperature of A is also the change in temperature of B, you are going to be having MC change in theta A equals to MC change in theta B. So of course these two are the same. So you have you are asked to calculate the ratio of their masses. So you have MA here, which will be multiplied by CA, equals to MB, which will be multiplied by CB. And okay, CB, okay. So what's our MA? Our CA is 3CB, which will be equals to MB times CB. So can CB cancel CB? Yes, it will. And if you do that very well, you are going to be having MA over MB. Let's see, MA over MB. That will be equal to, mind you, this is 1/3. Yes. So in that case, 1/3 is the same thing as 1/3, and that is option E. Yes, let's see question 24. We have a diagram here, which is of course a cooling curve. So the question is, we are to calculate the graph that represents the heating curve of a pure crystalline solid. So let's see, most especially since it's a cooling curve, is going to be dropping, and at a particular stage is going to be what? Constant, and at a particular stage it will be dropping also. So for a crystalline solid, if it is cooling, you have fall in temperature. The first stage, the second stage will be constant temperature, then the third stage will be drop in temperature. So let's see our A here. For the fact that this is showing increase, this is increase, constant increase, that's wrong. B is showing no change in the cooling curve, which is also wrong. Let's see C, drop, constant, drop. So the answer is C. So let's see question 24. In our question 24, we have a question here, and we're asked to calculate the quantity of heat absorbed. In most cases, you have MC change in theta, and a copper of heat capacity. We're given the heat capacity. Heat capacity is the same thing as what? Mass times specific heat capacity. So this is going to be this. So this is 400 multiplied by change in temperature. Change in temperature here will be what? 100 minus 20, which is what? 80. So here we are talking about 400 times 80. That should be 32,000. 32,000. That will be option B. Then let's see the next one, which is 25. A radio station broadcast at a frequency of 400 kilowatts. 400 kilowatts. We're given the speed and we're asked to calculate the wavelength. So this is V equals to what? F lambda. Establish that now. To calculate wavelength is going to be V over what? F. What's your V? V is 3.0 times 10 raised to the power 8 divided by frequency, which is 400 times 10 raised to the power 3. So this is going to be this in 3. So this is going to be 3 over 4. Of course, this is going to be 10 raised to the power 5. I'm converting everything here to what? Standard form. So this is going to be times 10 raised to the power 8 minus what? 5. And this is going to be 0. That should be 0.75, yes, times 10 raised to the power what? This is 3. So in that case, I can say 7.5 times 10 raised to the power 2 here. That would be in meters, and of course, that is option E. Yeah. Now 26. Which of the following is our longitudinal waves? If you check this very well, you have light waves from the sun. That is transverse wave. And B, sound waves in the air. This is longitudinal wave. Waves on a vibrating string. This is transverse. So this is transverse, this is transverse, this is longitudinal, and that's B, 2 only. Number 27. Which of the following pairs is an example of translucent bodies? If you check very well, translucent bodies are materials that allow light to pass through them, and through them it will be very difficult to see. And in this case, let's check the options that we have here. Cardboard, no, this is opaque. This is translucent, so of course the pair, that's the question. Following pairs, so this is wrong. Clear water and glass, this is correct. Frosted glass and wax paper, no. Oil, paper and brick, no. Wood, no. So the answer is B. So let's see 28. In question 28, an object is placed in front of a concave mirror whose radius of curvature is this. If the magnification of the image produces this, how far is the object from the mirror? So in this case, we're talking about the distance of the object from the mirror. You can go on and use your normal mirror's formula, which is 1 over F plus 1 over U. But since this is OBJ, I want to calculate my object distance. I have U equals to F bracket 1 plus 1 over M. You know why? Because I'm giving magnification. I've done my calculation here and I've derived it. So in most cases, I make use of this formula in solving my questions. So let's see, U here, focal length is half of the radius of curvature. So if this is 12, then this is 6. 1 plus concave mirror, we have a positive magnification. Yes, so you have 1 over, and the magnification is 1.5. 1.5 is 3 over 2, isn't it? Yes, so if I have 1 over M, then it's going to be 2 over 3. So I'm going to say 2 over 3 here. So quick one, let's see. If you find the LCM here, you're going to have U equal to 6 to be multiplied by 5 over 3. And if you multiply 2 by 5, the answer should give you 10. And check it very well, that will be option B. 10 is the answer. So 29, a nail is placed at the bottom of a block. So this is talking about the concept of real depth, and in that case, let's see. So we have bottom of a bucket which is filled with water to a depth of 20 centimeters. So that's talking about the real depth. So here you talk about R to be equal to 20, and here you have a nail somewhere here at the bottom. So let's see, at what depth will the nail appear to be when viewed from the top? When viewed from the top, let's assume you have it somewhere here. When viewed from the top, you have it somewhere there. And if that is the case, you're going to, from this point to where it appears to be, is called your apparent height, while from this point to this point is called your apparent displacement. But what we want to calculate here is the at what depth. So we are calculating the apparent depth. So in that case, we have n equals to real over the apparent depth, which means n is what, 1.33 equal to the real depth, which is 20, then divided by what, a, which is the apparent height. So quick one, a is going to be equal to 20 over 1.33, and if you punch your calculator there, you should get 15. Yeah, so let's check. 15 is there. That's option E. So let's see number 30. When a yellow card is viewed in blue light, a yellow card, yes, when viewed in a blue light, you agree with me that yellow, okay, don't worry, we have an acronym for that somewhere here. Check it very well. So I have because Musa ran, Yaya go see. So if that is the case, I have yellow. So yellow is made up of green and red. So green and red. And here we are adding it to blue. Blue is a primary color. And of course, yellow is a what? Is a secondary color. And if you check this very well, there's nothing that is similar here. So the answer here will be black. Black is our answer. But I did mean you have blue here, then blue can now mix with blue to give you blue. You understand? But in this case, nothing to mix. So the answer is A, which is black. So the next question is, which of the following radiation has the shortest wavelength? Do not forget reverse G. I have M here. So yeah, G here is talking about the wave, the electromagnetic wave with the what? Highest frequency. Highest frequency. Talk about the highest frequency here, and here you talk about radio wave with the highest wavelength. So in that way, if you move this way, what happens? You are reducing. They will be experiencing reduction in wavelength, and when you are moving from here to here, you will be experiencing an increase in wavelength. So here we're talking about shortest wavelength. Shortest should be between any of these two, in case you find any one of them there. Infrared, no. Light wave, which is visible light, no. Microwave, no. Ultraviolet, X-ray. You still have X-ray, so X-ray should have the one with the shortest wavelength, and that will be E. Now let's see the next question, 32. Which of the following is not a component of slide projector? Slide projector. In a slide projector, you have a concave mirror, you have a condenser. I'm not sure of convex mirror, so the answer here is convex mirror. Yes, I have the light source, I have my screen. Number 33. So here you talk about notes of the same frequency sounded on a guitar and trumpet may differ in with the same frequency. Okay, may differ in loudness, no. Pitch, no. Quality, yes, they will differ in quality, and that's three only. So this is C. Question 34. Which of the following is a percussion instrument? Do not forget, when we talk about instruments, we have three types of instruments. Let's see. Flute is a wind instrument, guitar is a string instrument, piano is a string instrument, trumpet is a wind instrument, while xylophone is a percussion instrument. And when you talk about percussion instrument is one in which a membrane is struck to produce the sound wave. So the answer to this question is a xylophone. 35. Which of the following statements is or are correct? Sound waves travels through air. This is correct. Vacuum, no. Water, this is correct. So we'll go for 1 and 3. 1 and 3 is your option C. Now, reflection of sound wave is not useful in, let's see, it is talking about the application of reflection of sound wave, which is echo. So let's say design of, yes, this is correct. Determination of ocean depth, correct. Determination of speed of, yes, this is correct. Exploration is correct. Production of motion pictures, no, this is not correct. So we are asked to determine the one that is not useful. So the answer to this question is E. Now let's see 37. A 12-volt battery supplies a current of 0.4 to a lamp. We are asked to calculate the resistance of the lamp. Here we use Ohm's law, which is V equals to what? IR. And if you do your calculation very well, the current is 0.4 times resistance is unknown, okay, which will be equals to the voltage. The voltage is 12. So in this case, you have your resistance to be 12 times 10 over 4. I'm actually writing this as 4 over 10. So let's see this here, that's 3. So if you multiply, you get 30 ohms. So 30 ohms is option A. Now let's see 38. The presence of charges on an object can be detected using A or AN. Okay, you can use this. You can use this, which is the gold leaf electroscope. The galvanometer is used to measure small amounts of current and the deflection of current in a conducting material. So that is not correct. So let's go to the question 39. The escape velocity of an object from the gravitational field of a planet increases with the mass. Okay. So the question now is, which of the following statement is or are correct? Now, when you talk about the escape velocity, generally escape velocity is given as the square root of 2gr. This is talking about the radius of the earth, or talking about the distance of an object from the center of the earth. So in that case, and but we know from what we have here, we can confidently say that V is directly proportional to the square root of G, isn't it? Yes, directly proportional. So that means increase in G will bring about increase in voltage, in escape velocity. So but we can also say that the acceleration due to gravity is also force over what? If you can remember, that is talking about the gravitational field intensity. So in this case, we all can say confidently that G is inversely proportional to M, because they mentioned M. That's what I'm trying to figure out, relationship between V, R, and M. So if V is directly proportional to G and G is inversely proportional to M, then V is inversely proportional to M, which is the bigger the size of that planet, the lower the escape velocity. So in that case, let's see, we have increase. No, as we have established here, this will be decrease. We have increase with the mass of the object, increase with the mass of the planet. This is not correct. None of these two is correct. Is smaller on the moon than on the earth. Yes, this is correct. G, the acceleration due to gravity on the moon, is less than that on the earth. So if that is the case, if G is less, that means the escape velocity will be small on the moon compared to that on the earth. So in that case, the answer to this question is 3 only. So let's see. Okay, so as you can see, there is no option here for 3 only, and that means this will be a bonus question. Let's go to question 40. Calculate the escape velocity of a satellite from the Earth's attraction. Talking about that, we use the formula V equals to the square root of 2gr. So if that is the case, we have 2 times 10 times r is 6.4. 6.4 times 10 raised to power what? 6. So in that case, if you punch your calculator here, your answer should be 1.1 times 10 raised to power 4 meter per second. So that is option C. Now let's see 41. Radio receivers are tuned using, you don't use electromagnets. No, you don't use inductors. Yes, you use a variable capacitor. That's talking about one of the applications of capacitors. Question 42. Which of the following is a desirable property of a fuse wire? So we have high expansivity, no. High thermal conductivity, low density, low electrical resistance. Yes, the answer is E, low melting point. Yes, a fuse generally is designed to have a low melting point in order for it to melt at the presence of a current that is higher than the preset value of that fuse. So that is why it is a form of a protective measure for electrical devices. Now let's see the second question. Okay, we have this question. I want to believe you all know your wisdom bridge. And in this question, we have used this information to answer question 43 and 44. The value of R is. So let's check. How do we go about question like this? It's very simple. I can say 4 divided by 3 equal to 2 divided by R, or I say 4 divided by 2 equal to 3 divided by R. Any of the two is correct. So yeah, I want to go by 4 divided by 3 equal to 2 divided by R. 2 divided by R. So in that case, 2 will cancel. Yeah, I have 2. So my R will be equal to 3 over 2. And that should give you 1.5. And okay, that's 1.5. So let's see the potential difference between P and Q is. Now let's check. We're told that in the diagram above, the galvanometer indicates a non-deflection. When this galvanometer or when this Wheatstone bridge is in a state of non-deflection, that means no current is flowing between the points given here. And when current is not flowing, your potential difference will be 0. So the answer to this is A. So let's go to the next one. An electric motor primarily converts, normally is electrical energy to mechanical energy. So let's check. No, electrical, yes, mechanical. So the next question is the angle between the geographical and the magnetic meridians at a place on the Earth's surface is the answer is angle of declination. And now let me just say this. We have angle of declination, and this angle of declination is also known as the angle of variation. So we also have the angle of dip. The angle of dip is also known as the angle of inclination. The angle of dip generally is the angle between the direction of the Earth's resultant magnetic field and the horizontal plane. So that will lead us to question 47. 2 straight long wires lie parallel and close to each other but not touching. Okay, if a steady current is passed through each of them in opposite, please note this word opposite. There we're talking about 2 conductors, 2 straight conductors, but here we have the current is passing through them in opposite direction. So in that case, I generally use the acronym OSA. Yeah, I use the word OSA. O here means when current is in opposite direction. So what happens to the magnetic field is going to be repulsive. So here we have repulsion, and X here stands for same, and A will automatically be attraction. So if that is the case, what we need here is the opposite direction, and since it's opposite direction, we will be having repulsion. So let's see. Okay, attract, no, the wire will not, the wire will oscillate, the wires will repel. Yes, that's option E. The wire will repel each other. That's repulsion. Now let's see 48. Calculate the magnitude of the force due to a magnetic field of this on an electron moving perpendicular. Perpendicular means theta is 90 degrees. Generally, this is the formula we use in solving question on the force experienced by a charge in a magnetic field. We have BQV sine theta. So in that case, where B is our magnetic field, or you call it the flux density. So in that case, it is 0.4 times Q, which is the charge here is 1.6 times 10 raised to power what? Minus 19. Then multiply by V, which is the velocity, and the speed is what? 4 times 10 raised to power what? 6. Then times sine theta. Sine theta. Theta is what? 90 degrees. For the fact that it is perpendicular, and if it is parallel, theta will be 0. So here we have sine theta. So if you punch your calculator here, you will have your F to be equal to 2.56 times 10 raised to power minus 13. That's option C. 49. Which of the following is not a component of an AC generator? generally we have an AC generator and we have a DC generator. So in this case, we have armature in both generators, we have carbon brushes in both, we have magnets in both, but this is what distinguishes AC generator from a DC generator. AC generator, they have a split rings, while DC generators, they have a split ring. So the question is, which of the following is not a component of an AC generator? So the answer is split ring. Now let's see, number 50, a voltage of 240 volts is connected to the coil, to the primary coil of a transformer. Now let's see, talking about a transformer, generally we have the number of turns in the primary coil over the number of turns in secondary coil equals to the voltage in the primary divided by the voltage in the secondary, which is also equals to the current in the secondary divided by the current in the primary. So in that case, once you understand this formula, all you have to do is pick out the two that actually fit into the question you are given. In this question, we have voltage and we are asked to calculate the number of primary turns. So we have voltage and turns, so I'll just go for these two and keep this somewhere. So now let's see, we are asked to calculate the ratio. Okay, so calculating the ratio, we have ns over np, np over nx, which is equals to, what's the voltage in the primary? Primary is 240, then divided by the voltage in the secondary, which is 15. So let's see, 5 here 3, 5 here is 48, yes, 3 here 1, 3 here is 1, 6. So here is 16 over 1. 16 over 1 is the same thing as 16 ratio 1. So let's see. Okay. Wow. So that means we have 16 over 1. 16 ratio 1 is the same thing as 16. Yeah. So that's D. Yep. So let's see. 51. Calculate the peak voltage that could be obtained from a 220 volt root mean square means supply. This is talking about AC current. And do not forget, in AC current, Vrmx equals to your peak voltage over the square root of 2. So we are asked to calculate that peak voltage, which will be Vrmx times the square root of 2. So what's the Vrmx is 220 times the square root of 2. If you punch your calculator there, you should get 3. Yes, you have 311.1 volts. Now, number 52. The voltage theory of light does not explain photoelectricity. Now, when you talk about photoelectricity, you are talking about particles. And when you talk about the wave theory of light, you're actually talking about the properties of waves, talking about diffraction, interference, and all of that. So now let's see. In this question, they are now asking why the wave theory of light does not explain photoelectricity, because light waves carry little energy. Is that not correct? Yes, talking about definition of wave. Wave can be defined as a disturbance transmitting energy from one point to another without, and I want to believe you know the rest of the story. B, particles cannot be emitted by waves. Yes, this is correct. Particles cannot be emitted by waves. Yes, this is not this is a reason, because yes, I'll go for this. Frequency of light, this is correct. There is a threshold, yes, talking about photoelectricity. This is also very, very correct, linking it with work function. And the wavelength of light waves is too short. This is correct, because the frequency is high, the wavelength will be short. Do not forget the relationship between frequency and wavelength. 53. Which of the following is used for shielding radioactive fallouts? Yes, that will be lead. Talking about lead can absorb all the 3 radiations of radioactivity emitted during radioactivity. So we have 54. Which of the following statement is correct? Alpha particles have a large mass. Okay, here we have mass and we have penetrating power. Okay, yes, mass penetrating power. Okay, mass penetrating. Okay, now that means in this question we want to compare the properties of alpha beta and gamma ray, talking about mass and their penetrating power. Generally, a gamma ray has no, or let's say zero mass, no mass, and the highest penetrating power, penetrating. Okay, permit me to quickly abbreviate it there. Penetrating power. And talking about alpha particles, they have the largest mass, let's say large mass, and the lowest penetrating power. Then what about beta particle? Beta particle, they are in between. So of course they also have mass, but not as large as alpha particle. They also penetrate, but not as powerful as that of gamma ray. So with this concept, let's see where our answer will be. Alpha particle has a larger mass, yes, that's correct, and a high, no. Alpha particle have a small mass, no. Beta particle have no mass, no. Beta particles have a large, no. And gamma rays have no mass, yes, and a high penetrating power, correct. So that would be my option E. So let's go to 55. Mercury does not wet glass because now generally when your force of adhesion, so let's say adhesive force, is greater than your cohesive force, then you wet glass. You must wet glass. But when your adhesive force is less than the cohesive force, then you do not wet glass. Do not wet glass. So what do we have here? So in that case, now what do you call adhesive force? Adhesive force is the force that exists between molecules of different material, while cohesive force is the force of attraction that exists between molecules of the same material. So in this case, we just want to go straight to mercury does not wet glass because glass is the adhesive force is, mind you, we said wet glass, isn't it? Yep. So now let's see, going by what you have, adhesive force is greater than cohesive force. Does not, this is less, not greater, so this is wrong. The cohesive force is greater than the adhesive force, which means adhesive force is less than the cohesive force. Yes, does not. So the answer here is C. And mercury has a very high thermal conductivity. This is the reason why you make use of mercury as a what do you call it now, as a thermometric substance in in liquid in glass thermometer. Mercury is opaque is one of the reasons to. So thank you. 56. The mercury column in a simple mercury barometer is of height 5 meters above the mercury in a reservoir. If the tube is replaced with one whose radius is twice that of the first tube, what will be the height of the mercury column in the new tube? Now, there's something you need to know. Talking about the barometer is used in measuring the atmospheric pressure of a particular location, and what really gives the reading of that pressure is the height of the mercury column in that reservoir. So now what this question is saying is, if this is the height of the let's say the barometer, now if this is the height of the barometer, so they're now saying that if it is now replaced with, let's say, test tube now of a higher radius, so which is radius is twice that of the first tube, what will be the height of the mercury? The truth is that if from here to if the mercury height is 5, here it will also be 5. There will be no change in the height of the mercury level. The truth is, the area of the test tube has nothing to do with the atmospheric pressure. The only thing that brings about reduction or change in this height is when you leave that place to another place. Let's say maybe to the top of a mountain and all of that. So that is when this height will change. But for you changing the height of the mercury, it has nothing to do with this question. So the answer is, if it is 5, it will also be 5. So that's B. Now, an element whose half-life is 10 days, okay, is of mass 12 grams. So the half-life of this element is 12 grams. Calculate the time during which 11.25 grams of the element would have decayed. Now, in this case, I'm just going to be solving this using a form of a chain. Now, let's see, in 10 days, the question is calculate the time. So that means we are on days. So 10 days, what happened to 12 grams? It would have decayed to half of its mass, which is the half-life, and that will be 6 grams. So now the mass decayed will be what? 6, isn't it? Yes. So now let's see, which is you can go ahead and say 12 minus 6, isn't it? So the mass decayed is 6 grams. So now let's see, after 10 days, the next day will be 20 days. Now 20 days, 6 grams would have decayed to what? Would have decayed to 3 grams. So now what will now be the mass decayed? Let me just say MD there. So the mass decayed will be what? 6 plus 3. Because now you're talking about the mass that have decayed from these 12 grams. So this will be 9 grams, isn't it? So after 20, you go to 30 days. Now 30 days, 3 grams would have decayed to what? 1.5 grams, isn't it? And in that case, the mass decayed will be 9 plus 1.5 grams, and that gives what? 10.5 grams, isn't it? After 30, as you can see, we've not gotten to what? 11.5. So all my addition here is to get 11.25 grams. So I'll keep working. After 30 days, I go to what? 40 days. Now for 40 days, what will happen to 1.5 grams? It would have decayed to 0.75 grams, isn't it? So what will now happen to the mass decayed? Mass decayed will be what? 10.5 plus 0.75. If you add that, okay, yes, that should give you 11.25 grams. And that is what you have here. So talking about the time is what? 40 days. And that is option E. Now, the next one is, what is the wavelength of the emitted radiation? This is talking about modern physics, talking about energy quantization and all of that. And here we have energy generally to be equal to the hf, which is a Planck constant multiplied by the frequency. So in that case, what happens? Frequency is also known as c over lambda. So here you have hc over what? Lambda. So can I just make lambda the subject of the formula? Okay, so that would be what? hc over e. So let's put in their values. Planck constant is 6.6 times 10 raised to the power minus 34 times c is 3.0 times 10 raised to the power 8. That's a constant. And what about the energy? Okay, now you have the energy, which is 1.5 times 10 raised to the power minus 19 joules. And at this point, you are free to punch your calculator. And if you do that very well, you will get 1.32 times 10 raised to the power minus 6. Now, 59. The charge of an alpha particle can be neutralized by, let's see, alpha particle generally is represented with the helium atom you have. Yes, and that is for alpha particle. Yes, then for beta particle, it is usually represented with electrons. Yes, so if that is the case, I want you to check this very well. Talking about the proton, the question is the charge of an atom of an alpha particle that can be neutralized by, so let's see, the charge here here we have 2, here we have -1. So if I multiply the beta particle by 2, I should get what? I should get 0 minus 2. So and here you can see if these two are made to react, this will neutralize this. So 1 beta particle is not correct. 2 protons of gamma rays, no, gamma rays in most cases you don't have any value for it, so that's why I'm not using it here to represent anything. So anytime you have a question like this, it's usually between alpha and beta particle. So here you have 2 beta particles. Yes, 2 beta particles. As I've said, if you multiply this by 2, you will get 0 minus 2e, which is your beta particle. So that would be option C. Then the last but not the least, which is question 60, the uncertainty principle can be most useful applied to measurement of, in most cases you don't include electrons, no space. That's talking about satellites. And okay, so the answer should be between this and this. Momentum of a football as it just reaches the goal position. This is talking about momentum. This can be your answer. Momentum of a train at a particular station. This is your answer. And that will be the end of this episode. Thank you and God bless you.